In this lecture, we will consider the social networking techniques for ranking of scientific publications like conference articles and journals, and research scholars also. The major techniques that we are going to cover is H-index and impact factor. So let us start with H-index. But before starting, we first describe some problems. Suppose you start research in some area, but due to huge scientific developments, there are a huge number of publications. Huge number of conferences, and journals, and similarly huge number of areas and sub areas. So when starting a work in a new research topic or brainstorming for a novel ideas, then the questions are: who are the expert in this field? What are the top conferences in this field? And what are the best papers? What are the top research labs? To get these answers, we can use some automatic techniques, because it is very tough to manually identify the results for every desired topics. Now we will use H-index to rank the conferences, journals, and even research scholars. But before going in detail, we first go through some definitions. The H-index is an index that attempts to measure both productivity and impact of the published work of a scientist or a scholar. The H-index is based on the distribution of citations received by a given researcher's publications according to the Hirsch, who developed the H-index. A scientist has H-index, or a scientist has index H if H of his or her NP public papers have at least H citations each, and the other NP minus H papers have no or not more than N citations each. This will clear from this picture. Suppose we represent citation as a y-axis and number of papers as x-axis, then we will get a diagonal line which represents the situation when number of citations and number of papers both are equal, and this is considered as H-index. This is the area lower H-index, known as lower H-index. For example, suppose an author has total 10 papers, and his 3 papers have citations and rest of the 7 papers has less than 3 citations, then author's H-index will be 3. But suppose an author has 10 papers and his first paper's citation is 25, second paper has citation only 1, and rest of the papers also have citation either 1 or 0, then his citation, his H index will be 1, because if we plot the graph of citation and papers, then H will point to 1 in this case. However, his first paper has very good or good number of citation. This may be a demerit of H index, but overall, if you see that this picture means if all 3 papers has 3 citations, then it represents the term like productivity and impact of the published work both, where this kind of impact factor just considers the impact of any single publications. Here it considers the both things. Now we will go through some use of H index. H index serves as an alternative to more traditional journal impact factor matrices in evaluation of impact of the work of particular researcher. By using same principle as given here, we can calculate the H index of any journals or articles. There is a tool, online tool available named as RNet Miner. It uses H index to calculate or rank the journals or conferences and even authors. Now the other very interesting use of H index is little semantic investigations has been made on how academic recognition correlates with H index over different over different institutions, nations and fields of study. For example, Hertz, the inventor of H index, suggested that for a physicist, a value of H of about 12 may be a good choice or maybe a basic qualification for associate professor. Similarly, H index having value 18 will be suitable for a full professorship. Similarly, 15 to 20 H index range may be suitable for fellowship in American Physical Society, and 45 or higher may be suitable for a membership in United States National Academy of Sciences. But there may be several problems with H index, like suppose a person publishes one paper and has a citation total 2000. Similarly, second paper has a citation 200, and after that he left the research. Then total 2 papers having citations greater than 2, so his H index will be only 2. However, his contribution is very high, but still, due to capture of productivity and impact both, it can be considered as a good measure for ranking of conferences, articles, journals and researchers. Now, calculation of H index. How to calculate H index? To calculate H index, we need some database. This database may be title of the paper plus authors, conference detail, and some other information. We can get such information from Google Scholar entries or DVLP database. For example, the H index can be manually determined using citation databases or using automatic tools. The database set can be obtained from Google Scholar entries or DVLP database or any other citation networks. Advantage of H index. The H index is intended to measure simultaneously quality and quantity of scientific output, both. Now here are some demerits. There are a number of situations in which H may provide misleading information about the scientist output. However, most of these are not exclusive to the H index. The H index, for example, the H index does not account for the number of authors for a paper. For example, suppose you write a paper with total 10 authors, and this paper's citation has 2. Similarly, you write second paper with only 2 authors having citation 2, then your H index will be 2. However, in first case you have used 10 authors, and in second case you have 2 authors. You are 2 authors. So it does not consider these things. Similarly, H index does not account for the typical number of citations in different fields. Different fields of journals traditionally use different number of citations. For example, in some new or starting field, there may be huge number of citations, while in some saturated field, there may be less number of citations. Now, some other demerits of H indexes are: the H index discards the information contained in author placement in the author list. Means whether author is first author. For example, suppose you publish a paper and this paper contains author A and B, 2 author, A, B and C, 3 author, and this paper citation is total 2. Similarly, in another paper, the authors are D and A, 2 authors, and its citation is also 2, but here the authors A are common. Author A is common in this authors list, so the H index will calculate the H index for author A is equal to 2. This is one of the demerits, but there may be some corrections to solve this problem. The H index is bounded by the total number of publications. It is clear from the previous examples that it is already uses the count of publications. The H index does not consider the context of citation. Context of citations can be like where the paper got cited, either in conference or in journal, and what are the level of both conferences and journals. H index does not consider these things. The H index gives books the same count as article, making it difficult to compare scholars in the field that more book oriented, such as humanities. Means instead of using the research papers, some books or articles, review articles can be counted for calculation of H index. This is another demerit, but I think it can be solved. Now other demerit is the H index does not account for confounding factors such as gratuitous authorship, the so-called Matthew effect, and favorable citations biased associated with review articles. Means to enhance the impact or number of citations, several journal articles or conferences publish review articles, and H index does not account for such confounding factors. H index has been found to have a slightly less predictive accuracy and precision than simpler measure of the mean citations as paper. The H index is a natural number which reduces its discriminatory power. The H index can be manipulated through self citations, and if biased and if based on Google Scholar output, then even computer generated documents can be used for that purpose. Example, using science generator. Now some alternative and modifications that can be used to modify the H index. An individual H index normalized by average number of co-authors in H score has been introduced by Batista et al. Another thing is the use of M index. But I think first we should describe what is this. Actually, Batista et al. Found that the distribution of H index, although it depends on the field, can be normalized by a simple rescaling factor. For example, assuming that standard the H for biology, the distribution of H for mathematics may be different. Means for different area, the value of H or its impacts may be different, because in some area or some growing area or new area, we can publish more number of papers, we can get more citations, and thus it might be simpler to divide citation count by the number of authors before ordering the paper and obtaining the H index, as originally suggested by Hirsch. The another thing is M index. The M index is defined as H by N, where N is the number of years since the first published paper of scientist, also called M quotient. Here M index, instead of using direct H value, it divides the value of H by N, where N is the number of years since the first publications of paper of the scientist. Another modification, a generalization of H index and some of his indices that gives the additional information about the shape of author's citation function. For example, heavy-tailed, flat, picked, etc. was proposed by two authors. Jaglowski and Gregorowski. Means in some case the citations like heavy citations, in some cases flat citation, in some cases means different natures can be used to modify the score of H index. For another modification means successive Hurst type index introduced independently by Komlowski and Pratap. A scientific institution has a successive Hurst type index of I. When at least I researchers from that institution have means if for any institution if at least I researcher from that institution and each have an H index at least I. So we can use such kind of successive information in modification of traditional H index, because it represents the research environment of the institution. Another modifications urges that for an individual researcher, measures such as Erdos number means suppose an author A writes a paper with author B and author B. Similarly, after that author B writes a paper with another author C. As now C doesn't write any paper with author A, then there is a gap between author A and C which is equal to 2. This gap is known as Erdos number. It represents the gap between authors. So, and generally used in calculation of impact or importance in mathematical journals. So for an individual researcher, a measure such as Erdos number captures the structural property of network, where the H index capture the citation impact of the publications. For example, as I discussed, what are the network, author network that captured by Erdos number, and similarly you already know the H index just capture the citation impact of the publications. One can be easily convinced that the ranking in co-authorship network should take into account both measure to generate a realistic and acceptable ranking. Several author ranking system such as eigenfactor, based on eigenvector centrality, have been proposed already to solve such problems. Now other modifications may be the C index accounts not only for the citations but for the quality of the citation in terms of the collaboration distance between citing and cited authors. A scientist has a C index n if n of his or her n citations are from authors which are at collaboration distance at least n, and other n minus n citations are from authors which are at collaboration distance at most n. Thus it utilizes both collaboration distance between the citations and the count of citations both, and instead of using h, it is represented as C index. Now other modifications suggested by Borman, Mudge and Daniel recently proposed 3 additional matrices like H2 lower, H2 center and H2 upper to give more accurate representation of distribution shape. H2 lower considers the conference articles, conferences or journals having low impact area, while H2 centers considers the conferences or journals captured by H index, and similarly H2 upper considers the area from publications with highest visibility. Publications with highest visibility. Now this is an example of H index. In this example we consider the author ranking, and this data is copied from Arnet Miner. This is a source and it represents the rank of authors based on the H index value. Now the other technique to rank the conferences or journals is impact factor. Definition: the impact factor, often abbreviated as IF, is a measure reflecting the average number of citations to articles published in a science and a social science journals. Very useful in ranking of conferences, journals and research scholars. Calculation: in a given year, the impact factor of a journal is the average number of citations received per paper published in that journal during the 2 preceding years. For example, if a journal has an impact factor of 3 in 2008, then its paper published in 2006 and 2007 received 3 citations each on average in 2008. The 2008 impact factor of a journal would be the calculation as follows. For example, A is the number of times article published in 2006 and 2007 were cited by indexed journal during 2008, and B is equal to total number of citable terms published by that journal in 2006 and 2007. Citable terms means papers, either maybe conference paper or journal or journals. The citable items usually articles, reviews, proceedings or notes, non-editorials or letter to the editor. These are the some extra things. instead of just considering paper and journals, it considers articles, reviews, notes, or later to not editors or later to the editors, not editorials or later to the editors. Means it includes the review articles and notes. For example, suppose in 2006 paper published in 2006 and 2007 got total 8 citations. Suppose total 4 papers published in a journal in 2006 and 2007 and got total 8 citations. Then average number of citations per paper is 2. They got 8 citations during 2008 or till 2008. So average number of citations per paper is just 2. So that journal's impact factor will be 2. But this calculation contains a lot of loopholes. For example, after publishing 4 papers by a journal during 2006 or 7, they found that their citation is just 5. Their citation is just 5. So what they did, after that they write some editorials and cite each papers. Then total citations will be 9. So the average number of citations will be more than 2, and thus by using such kind of technique or management, they can increase their citations. And this is, I think, one of the demerit of impact factor. However, impact factor is generally very useful for ranking conferences and journals. Now, some important factor or what are the merits or demerits of impact factor. First is the impact factor is highly discipline dependent. Means the percentage of total citations occurring in the first 2 years after publications varies highly among the disciplines, from 1 to 3% in the mathematical and physical science, 5 to 8% in the biological science, etc. Means we can say that publications or in related to the field, growing field, may got higher citation. Similarly, saturated fields paper will get lower citation. Other thing is the impact factor could not be reproduced in an independent audit. It always requires some database and some background information about number of citations and period. The impact factor refers to the average number of citations per paper, but This is not a normal distribution. This is rather a Bradford distribution as predicted by theory. Journal ranking list constructed based on the impact factor moderately correlate with journal ranking list based on the results of expert survey. This may be a demerit, but still it is used, highly used, and due to this demerit, we cannot strictly depend on impact factor to rank the conferences and journals, but we can take some guidance to identify the important journals and conferences. For example, in this example, I have used a CiteSeer database, some few entries of CiteSeer database generated from documents in the CiteSeerX database as of March 20th, 2008. This list is automatically generated and may contain some errors. The impact is estimated based on Garfield's traditional impact factor. Venue details obtained from DVLP by Michael Lay. Means in the calculation of these impact factors, they use the DVLP database, and they used previous years publications like 2006, 7, before 2008, and based on their ranking, they order the conferences in descending order of their impact factor values. There is another example on impact factor. This is related to Microsoft Academic Search. We can get this information from academic search, academic.research.microsoft.com rank list. It ranks the conferences on the basis of publications and citations, and after that this impact factor can be calculated. So I just used top 10 conferences by impact factor related to the subject, algorithms, and theory. Now these are the references.